Welcome to 3 Inquisitive Kids. In these videos, we're going to be solving some problems about arithmetic and geometric progressions. Let a sub n be a finite arithmetic progression and k be a natural number. The first term is equal to r and it's negative, and a sub k is equal to 0. Find the sum of the first 2k minus 1 elements of the progression. Let's write out what we know so far. We know we have a1, ak, and a2k minus 1. We know that a sub k is 0. How can we try to express the values of a sub 1 and a sub 2k minus 1 based off of this a sub k? Well, in order to get to ak, you had to start from the first term, right? So it had to be a sub 1 plus a k minus 1 amount of common differences to get to 0. So a1 must be equal to negative k minus 1 times d. Now what about a sub 2k minus 1? Well, you had to start from ak and then add a certain amount of common differences. And in this case, the certain amount would be 2k minus 1 minus k. And this would be equal to 0 plus k minus 1d. So a sub 2k minus 1 is equal to k minus 1 times the common difference. Now we notice that a1 and a sub 2k minus 1 are additive inverses. They're opposites, which means they sum to 0. And because we have a common difference, they're all equally spaced apart, all the terms. The second term and the second to last term will also be additive inverses. So when they add together, when we pair them together, they're always going to equal 0. Which means in the end, even though we don't know what k is, the sum of all of these terms is 0 because they are symmetrical about 0.